For over half a century, the moon has been a quiet monument to a past era of exploration. Since the last Apollo mission in 1972, no human has set foot on its dusty surface. We've sent probes to the far reaches of the solar system, rovers to Mars, and telescopes beyond the stars. But the moon remained untouched. Until now, a new era has dawned, not of flags and footprints, but of infrastructure and permanence. Not a race to beat another nation, but a step toward another planet. At the center of this new vision lies one name: Gateway. NASA, in collaboration with international space agencies and commercial partners, is building a space station in lunar orbit, one that will serve as a waypoint between Earth and deep space. This is not science fiction. Construction has already begun, and when complete, Gateway will become the first deep space outpost humanity has ever built. But Gateway is more than a station. It is a strategy, a launch pad, a rehearsal. It's the stepping stone to Mars and beyond. Since the early 2000s, the International Space Station has served as a testbed for long-duration spaceflight. Orbiting Earth every 90 minutes, it has taught us how to survive in microgravity, recycle water, and perform science in space. But the ISS is just 400 kilometers above Earth, a short ride by space standards. To reach Mars, we must go farther. We must leave Earth's gravitational pull, and with it, the protection of its magnetic field and easy supply chains. Enter Gateway, a station designed to orbit the moon, not the Earth. It will sit in a near-rectilinear halo orbit, NRHO, an elongated path that offers both constant solar exposure and access to the moon's poles, where water ice awaits beneath the shadows. This orbit will allow Gateway to serve as a staging point, not only for moon landings, but for missions to the Red Planet. For the first time, we will establish a permanent presence beyond low Earth orbit. Gateway will be small, at first, roughly 1/6 the size of the ISS. Its core elements will include the Power and Propulsion Element, PPE, providing solar power and ion propulsion. The Habitation and Logistics Outpost, HALO, a pressurized module for crew living and science. Docking ports for visiting spacecraft, cargo ships, and lunar landers. The IHAB module, built with European and Japanese collaboration, expanding habitation capacity. And eventually, science modules, robotic arms, and communication relays. Gateway is designed to be modular, flexible, and autonomous, capable of supporting both short-term astronaut visits and long-duration robotic operations. Unlike the ISS, it won't be continuously crewed. Crews will visit for 30 to 90 days during Artemis missions, bringing supplies, conducting science, and preparing for what comes next. In essence, Gateway is a gas station, garage, and launch control center, all in lunar orbit. Why return to the moon at all? The answers are strategic and scientific. At the moon's south pole, hidden in permanently shadowed craters, lies a priceless resource: water ice. This ice can be extracted, purified, and split into hydrogen and oxygen, the same elements used in rocket fuel. It can support life. It can support launches. For a Mars mission, launching from Earth with everything we need is inefficient and costly. But launching from the moon, using local resources, could reduce mission mass by over 60%. Gateway enables this vision. By acting as a refueling and assembly point, it lets spacecraft arrive in stages, link up, resupply, and launch toward Mars with much lower delta-V requirements. And the moon's proximity, just 3 days away, makes it the perfect training ground for landings, for life support testing, for emergency response. Before we commit astronauts to months of deep space travel, we test everything at Gateway. Gateway is part of a larger architecture, the Artemis program. Named for Apollo's twin sister, Artemis represents humanity's return to the moon, and this time, we're not coming alone or briefly. Under Artemis, NASA and its partners plan to land the first woman and first person of color on the moon, establish a base camp near the lunar South Pole, test new technologies for power, habitation, mobility, and excavation. Gateway is central to this vision. It serves as a command center for lunar operations, a parking orbit for landers, a science platform for studying solar radiation, geology, and life support systems in deep space. And most importantly, it's a rehearsal stage for Mars. The systems we test at Gateway, from life support to solar electric propulsion, are the same systems we'll use on multi-year missions to the Red Planet. Gateway isn't just a NASA project. It's a global partnership involving the European Space Agency, ESA, the Japan Aerospace Exploration Agency, JAXA, the Canadian Space Agency, CSA, and commercial players like SpaceX, Northrop Grumman, and Maxar Technologies. Canada is building the Canadarm3, an AI-powered robotic arm that will operate and repair Gateway autonomously. ESA and JAXA are building the IHAB module, providing life support, storage, and crew systems. SpaceX's Starship is developing the lunar lander that will ferry astronauts from Gateway to the moon's surface. And robotic logistics missions, launched aboard Falcon Heavy rockets, will deliver cargo, spare parts, and fuel. This hybrid model of national agencies and private industry represents a new blueprint for space exploration. Not competition, but collaboration. Not one flag on the moon, but many. Building a space station around the moon isn't easy. Gateway must survive. Radiation levels far higher than those in low Earth orbit. Communication delays with Earth, up to several seconds. Thermal extremes, as it swings between sunlight and shadow, and the constant threat of micrometeoroid impacts. It must be autonomous, able to function without a crew for months. It must support AI diagnostics, robotic repair, and in-situ decision-making. The design of Gateway incorporates lessons from decades of spaceflight, but it also pushes the boundaries of what's possible. Because these are the same challenges we'll face on Mars. The same solar flares, the same comm delays, the same need for self-reliant infrastructure. Gateway is not just about going to the moon. It's about learning to survive without Earth. Mars, the red planet, a cold, desolate world, and yet the most Earth-like body in our solar system. For decades, it has beckoned as the next great frontier. Now, thanks to Gateway, that dream may be closer than ever. From lunar orbit, we can assemble a Mars transfer vehicle, a spacecraft large enough to carry astronauts, supplies, radiation shielding, and power systems for the long journey ahead. We can launch it in segments, test it at Gateway, fueled at Gateway, crewed from Gateway. Astronauts will train in the moon's lower gravity, practice surface EVAs, and simulate Mars landing procedures, all within the safety net of Earth's proximity. In doing so, we reduce the unknowns, we mitigate the risks, and we build the confidence needed for interplanetary travel. Gateway is the last outpost before we step into the void. In the years ahead, Gateway will rise piece by piece, a new symbol in the lunar sky. It will not be visible to the naked eye, but its impact will be. Because Gateway is more than a station. It is the future of exploration, built in modules and dreams. A bridge between Earth and everything beyond. A rehearsal for Mars. A monument to what we can do, together. It marks the moment when we stopped circling Earth and began leaving it, to return to the moon, to explore Mars, to become not just spacefarers, but space settlers.